Okay, and so number 1, it's already factored for me. So 3 times x plus 7 squared times x minus 7 cubed. You don't have to do this, what I'm fixing to write down, but let's just think about what that means. This would be x plus 7 times x plus 7 because it's squared. And the x minus 7 cubed, that means that's going to be a factor 3 times. So when I solve that to find my intercepts, right here would give negative 7, and that would happen twice, right, because it was raised to the second power. So we know negative 7 should have a multiplicity of 2, and then these 3 would give positive 7, and because that happened 3 times, 7 would have a multiplicity of 3. So the answer there should be A. Okay, so I'm told to find which of these is the correct graph for the function. So the main thing to help me with rational functions would be looking at the asymptotes. So we can find the vertical asymptotes by setting the denominator equal to 0. So at x equals 4, I have a vertical asymptote. So when I look on my graphs, it looks like the x values are going up by 2 because you see they tell me that's 10. So this would be 2, 4. So that one has a vertical asymptote at 4, so that's possible. This one here, 2, 4. This vertical asymptote is not at 4, so I know it's not B. C, 2, 4. Okay, that one's a possibility. And then D, 2, 4. It looks like there's some kind of vertical asymptote there. But it looks like there's also a vertical asymptote at 1. You see how that one has 2 different vertical asymptotes? Well, I know the only place there should be an asymptote that's vertical would be at 4. So I can eliminate D as well. So now then, to choose between A and C, I'm going to look at the horizontal asymptotes. So I'm comparing the degree of the numerator and denominator. Since they are both degree 1, then I know I have a horizontal asymptote at y equals the leading coefficients. So that would be 1 over 1, which is y equals 1. So the horizontal line at y equals 1. For C, it's at negative 1, so that would be wrong. And at A, it's at positive 1, so that should be the correct answer. Okay, on 7, I need to solve this quadratic inequality by graphing. So right now, it's not a quadratic because you have a variable on the right and a variable on the left. So I want to get them all to the same side. I'd move 3x over, it becomes negative. So now I have a quadratic must be less than 0. So what does that mean if the quadratic is less than 0? Well, that's going to mean, again, I know this is a parabola. I know it's facing up because my leading coefficient is positive. So I'm going to have something that looks like this. Where it's less than 0 is where it goes beneath the x-axis. So what I can do is I can find these x-intercepts, and I know between those x-intercepts that this quadratic is going to be negative. So to find the x-intercepts, we could either factor or use the quadratic formula. This does not look like it's easily factored, so I'm going to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that's going to be 3 plus or minus the square root of 9 minus 36 is negative 27. So I know I'm taking the square root of a negative number, which will not give me a real answer. It will give me an imaginary answer, which means there are no real x-intercepts. So my graph must look something like what's in the yellow here, where it's going to change its direction but never get to the x-axis. So it has no x-intercepts, so that means it's never going to be beneath the x-axis. So I could say that this one is B, no solution. Okay, so we got a varies problem. So we've got something that varies both directly and inversely. So we just read it. Y varies directly with x. So that means I have y equals kx. And it's inversely with the square root of w. So I just write out exactly what it tells me. Y varies directly as x and inversely with the square root of w. Now I've got one situation here. I plug in all those numbers so I can find k. So that's going to be 18 equals k times 3 over the square root of 20. And then I want to simplify this. So that's going to be, I would cross multiply. So that's going to be 3k equals 18 radical 20. Divide by 3. So that's going to give me k equals 6 radical 20, which if you put that in your calculator, that will simplify because radical 20 will break down as 4 and 5. So that should be 12 radical 5 is what we should get there. So I know that the k value is 12 radical 5. So I take that information, plug it back into my original. So now I have k is always 12 radical 5. Now plug in the new situation. So now I know x is 2. And I know, and this should be a square root of w, my fault. And I know w is 45. So that's going to give square root of 45. That's 9 times 5. So that would be 3 radical 5. So I've got 12. Sorry. Let me fix the top. 12 times 2 should be 24 radical 5 over, this will be 3 radical 5. 24 over 3 is 8, and the radical 5s cancel. So I should get y is equal to 8. So the correct answer there would be D. Okay, an archer shoots an arrow straight upward with an initial velocity of 160 feet per second from a height of 9 feet. Then its height above the ground in feet at time t in seconds is given by the function h of t equals negative 16t squared plus 160t plus 9. What is the maximum height reached of the arrow? So first thing I want to do, find the maximum height. Well, I know this is a parabola. I know it's facing downward because the leading coefficient is negative. And I know that the y represents the height of the arrow. So if I want to know its maximum height, that would happen at the vertex because that's when the y value is its highest. So to find the vertex, I would use the formula to find the axis of symmetry, which is x equals negative b over 2 times a. Okay, if I simplify that, negative 16 and negative 160 would give positive 10, and then 10 over 2 would be 5. So we would get x equals 5 is the axis of symmetry. So that means at 5 is where it reaches its highest value. So to find what that value is, we're going to plug 5 into the formula. So it's going to be negative 16 times 5 squared plus 160 times 5 plus 9. I'm going to have to use my calculator on this one. So that's 25 times negative 16. That's going to be negative 400. 160 times 5 is going to be 800 plus 9. So that should be 409 is the maximum height reached of the arrow. I'm going to double check that, make sure that's correct. Number 14. Yes, that's correct. So the maximum height is 409. Now the second thing we need to do is we want to know how long does it take for the arrow to reach the ground. So again, when I'm thinking back on what my graph looks like, I know that the y represents the height of the arrow. So it's going to go up, and when it reaches the ground is going to be when the y value is 0. So to find that, we know we're just looking for an x-intercept. So to find the x-intercept of a parabola, we could either factor or use the quadratic formula. So for this one, again, I'm going to use the quadratic formula. So x equals negative b plus or minus square root of b squared. I can't do that in my head. Minus 4 times a times c all over 2 times a. It's going to be negative 32. So give me just a second. Let me work that out. 160 times 160 is 25,600. 4 times 16 times 9. That's going to be positive 576. So I'm taking the square root of that. Negative 160 plus or minus over negative 32. Okay, so 576 plus 2, 5600, 26,176. And then I'm taking the square root of that. I know you can just put this in your calculator. I get 161.789. And now I have to do either plus or minus. So I know going into it, I'm going to be using the minus. because I'm dividing by negative here. So I need to make sure I get the most positive value, because this is going to have two x-intercepts, and one of them is going to be a negative number, which does not make sense because we're dealing with time. So I know that the negative x-intercept is not the correct one. So it's going to be the subtraction one. So 161.7, make that negative, and then negative 160, and then divided by negative 32, I got 10.055. So when I round that to the nearest hundredth, it'll be 10.06, which is the correct answer for B. Find all the real and imaginary roots stating the multiplicity of each. So I've got x to the fourth minus 29x squared plus 100 equals 0. So you've got a couple ways you could work this. Because it's an x to the fourth, you could use synthetic division to test some possible roots and see which ones work. And that's not a bad option here because it tells me which ones to try, right? I mean, it's already laid out for me here. So if you wanted to go the synthetic division route, you would try these numbers up in the box, and whichever ones gave you a 0 remainder would be your roots, and then just see how many times each one of those happened. But you could also factor this because it's a trinomial. So that's the way I would work this problem if I saw it. I would say what multiplies to be 100 added or subtracted is negative 29. Well, that's going to be a negative 25x squared and a negative 4x squared. So I bring x to the fourth down plus 100, and we can factor by grouping. So my GCF would be x squared. That's x squared minus 25. And then in the second one, it's a negative 4, which leaves me with x squared minus 25. So I have x squared minus 4, and I have x squared minus 25 equals 0. Set each one of those equals 0. So x squared equals 4, which means x equals plus or minus 2. Remember, when you take a square root, you always account for the plus or minus. And then same thing here, plus or minus 5 when we take a square root there. So I have 4 roots, 2, negative 2, 5, negative 5. So each one can only happen one time. So that would be C. So this is the one, if you remember, you asked me one like this on your homework questions. And these are not difficult. You just have to make sure you know what you're thinking about. I'm given a graph of a rational function. I want to first identify the domain, so that's the possible x values. Well, the only place I have a problem with my x values is where I have a vertical asymptote, which happens right here. So that's at negative 1, 2, 3, 4. It's at negative 5. So my domain would be everything but negative 5. The domain is from negative infinity to negative 5, and from negative 5 to infinity. Now again, we just talked about the vertical asymptote happened when x equaled negative 5, so that would be your answer there. And then the horizontal asymptote, again, just looking at the graph, what's the equation for this horizontal asymptote? That would be at y equals 1. So that would be it for 21. I'm going to let you work this one. This is just like the arrow from before that we worked. If you want to find the maximum height, you need to find the axis of symmetry. And then whatever x value you get, plug it in to find the y value. So, again, just like the arrow one from before, I'll let you practice working that one out. Okay, so first we need to find the x-intercepts. So, I would factor this. I would get the GCF. So, the GCF here would be x squared. Factor that out. That leaves you with x minus 10. And remember, x-intercepts happen when the y value is 0, so just plugging in 0 for y there. Now set each one of those parentheses, or each one of those factors equal to 0. X squared equals 0, x minus 10 equals 0. So I would get x equals plus or minus 0, which is just 0, and x equals 10 here. So my two x-intercepts are at 0 and 10. So it tells me to type an ordered pair, so that'd be 0, 0, and 10, 0. For my two x-intercepts. Now right here, since this was x squared, remember it was plus or minus 0. So that means 0 happens twice. So at 0, the graph is just going to touch the x-axis, not cross it. So right here, it touches at 0, 0, and it's going to cross at 10, 0, because that's the x-intercept with a multiplicity of 1. Okay, so another joint variation problem. The weight of a can of soup varies jointly with the height and the square of the diameter. So I would set that up. Weight equals K times H for the height, and the square of the diameter would be D squared. Now we use the information to find K. So it tells me it's 4 inches high. So I have a height of 4. Have a diameter of 2. It's 2 squared. And its weight is 6.4. Equals K. Now simplify that out. So 4 times 2 squared is going to be 16. So I've got 16K equals 6.4. Then divide by 16, we get K equals 0.4. So I know what K is equal to. So substitute that back into the original. Now substitute in the new situation. So we know the weight of the can is 7 inches. Sorry. What is the weight of the can? That is 7 inches high. So I've got a height of 7, and its diameter is 4. So that's going to be 4 squared. So that would be 4 squared is 16. 16 times 0.4. 16 times 0.4, 32, 64, 6.4. And then 6.4 times 7, that would be 28 and 56. That's going to be 58.8. So the weight there should be 58.8. Okay, so this one works the same as the problem before, so I'll show you the setup and then I'll let you do the math. Bob believes his test grade varies directly. So grade varies directly with the number of hours he spends studying, and inversely with the number of hours he spends playing baseball. So that would be the setup, and then just do the same thing we did on the last problem. Okay, and here's 32. Construct a function that expresses the relationship in the following statement. Use K as the constant of variation. Cost of construction, a silo A varies jointly as the height and the radius. Okay, so I've got the cost of constructing a silo, A, so that's the cost, varies jointly, so K, as the height, U, and the radius, Q. So that would be my formula. I just have to use the variables they give me. So A is the cost, U is the height, Q is the radius, and it has an understood K in there.